So we're back. So graphing quadratics from standard form. Now you're like, well, I can just go to my calculator. Well, yeah, okay, but sometimes you need like more exact information than what your calculator can give you. And then sometimes it's just good to have a calculator to like check your work for you. All right, so plus also when you have a test, you're gonna have to show me this work. So that's another good reason. All right, so as we remember from yesterday, standard form of a quadratic is f of x, but we like don't use that super much in here. So we all know that means y. I mean, for the most part. So we're just going to put y. All right, so y equals ax squared plus bx plus c, or minus, or whatever. So today we're going to use this to find several things. And that, first of all, is whether a parabola opens up or down. And I know, like, there's not enough room in these little boxes to do it. We're also going to find the axis of symmetry. And what that means is, like, symmetry, of course, is like you find the line of symmetry, which is that's an axis, right? So you can just call it that if you want to. But it's like if you fold it over, it's the same on both sides. And then we use this equation and also the axis of symmetry to find the vertex, which is the vertex is the turning point, right? So if you're ever also asked for like a minimum or a maximum, that's the vertex, right? So a minimum on this would be like at the bottom right here. Maximum would be like the highest point, which is right there. All right. And then also the y-intercept. We do use this, and if you remember yesterday, the x-intercepts are our solutions. So like we're not going to do that again today just yet. So that's tomorrow. But for looking, we want to identify all these things on this particular graph right here. So this box at the top, it is pointing to this line, which is the axis of symmetry. Because again, if you could take this and like fold it over this line, they would be the exact same on both sides. This bottom one right here is pointing to the vertex. Again, that turning point, in this case, a minimum. And then this box right here is pointing to that point where it crosses the y-axis, so that's the y-intercept. All right, so you're like, well, gosh, that was easy. I can just point all that stuff out. Yeah, but like, so here we're going to do it from an equation. And then you have to graph that stuff. All right, so first we're going to talk about, does it open up or down? Then we're going to do the axis of symmetry. Then we're going to do the vertex, then the y-intercept. So, does it open up or down? This is actually super easy. This is decided by A, as in like ax squared plus bx plus c. So like that A. Literally, it's this easy. If A is a positive number, it opens up. So this like f of x or y, whatever, equals ax squared plus bx plus c. A is positive, so it's a smiley parabola. Because it's positive. Okay. A is negative. It opens, as you might expect, down. So here, A is negative. So that's going to be a negative sad parabola. And it opens down. All right. So far, so good? Super easy. Okay. Axis of symmetry, also easy. You just have to make sure you get the right numbers. So there's a specific formula, and it's x equals negative b over 2a. And it's x because you're finding this point, like this line, like this axis of symmetry. Remember how vertical lines are like x equals a number, okay? So that's this, like you're finding that x value, that number where the vertex is going to go through, okay? So like if you were to look at this point right here, this vertex, you go, okay, 1, 2, 3. Well, x equals 3, that's the next. Sorry. And then y is 1, 2, 3, 4, 5, 6, negative 6. So you're trying to find, like, this point is 3, negative 6. And, like, you have to figure that out. And there's a way to figure that out. And it's by using this x equals negative b over 2a. So, of course, again, b comes from b, a comes from a. So let's say if we had y equals 3x squared plus 4x minus 5, you would plug in, like, 4 is b, 3 is a. So negative b, I'm getting myself a little room here, sorry. Negative b is negative 4 over 2 times, it's always 2, that 2 is always there, doesn't matter what number a is, 2 times 3. So negative 4 over 6, so negative 2/3, or, negative 0.66. So there's two things to understand. First of all, this axis of symmetry is not always a nice whole number. The other thing is, like, when you're looking at this negative b, I shouldn't say negative, I should say opposite. Because if b is already negative, then that has to become positive. So it's the opposite of b. All right. So the axis of symmetry, you actually use that to find the vertex. So the axis of symmetry is the x coordinate of your vertex. And, like, if I told you to say, okay, I have y equals 3x squared plus 2x plus 10. And I want, sorry, that's a plus. And I want you to evaluate it at x equals 4. Okay. So if I'm looking at this, what you would do is you go, well, 3 times 4 squared plus 2 times 4 plus 10. Right? So 3 times 16 plus 8 plus 10. So that's 48 plus 8 plus 10. I don't know why I continue to write, like, all of this out like this. Sorry. So 56 plus 10, or 66. So your y value in this particular thing would be 66. Well, your x value was 4. So whatever, the point is 466, right? So this is what you're trying to find, except this 4 would be the x coordinate of your axis of symmetry. And then you just take that and you plug it into the equation, okay? So it says after you find the axis of symmetry, plug that in for x into the equation like that. So like we just did, right? So if x equals 2, then this is going to be like whatever times 2 squared plus whatever times 2 plus c. And then whatever you get is your function. Like if this was 2, then whatever you got when you plugged it in, that would go there. And this entire coordinate now is your vertex. Okay, that one is like, that's the only part of this that gets a little confusing. So I hope that it makes a little bit more sense once we actually do it. All right, so your y-intercept, you're like, oh my gosh, please no more. So easy. You get it from the c value. And so it's literally, like, remember how the y-intercept, like it goes like that, right? Your y-intercept is here. That's a really big point. So every single time, your x coordinate of a y-intercept is 0. And then whatever the y value is. So literally your y-intercept is 0, c. So whatever this number is. Now let's say you only have y equals ax squared plus bx. You're like, well, I don't have a c. Okay, well then it's 0. 0, 0. That's where it goes through. Okay, so let's try this a couple of times. All right. So using the function, again, I don't know why, but affected all this. Y equals 2x squared plus 8x minus 5, find the following. First, let's get our a, b, and c. So a is 2, b is 8, c is negative 5. We know that from factoring. Okay, which way does it open? Well, A is positive, so it opens up. It's a happy parabola. Axis of symmetry. Now, negative B, or opposite of B, remember, over 2 times A. B is 8. 2 is A. So I have negative or opposite of 8 over 2 times A, which is also 2. I'm going to take a minute right here to make sure that you put this in your calculator correctly. Let's see if I set my calculator up. Oh dear, what just happened? Apparently not. So I guess I don't. But anyway, what I want you to know is that when you put this in your calculator, either put it in as a fraction, so make it actually look like that, okay? Or like do this math first and then have it as negative 8 over 4, which would be smart. But if you put negative 8 divided by 2 times 2, it'll take negative 8, divide it by 2 and get negative 4, and then multiply that again by 2, which is 8. You don't want that. So negative 8 divided by 4 is negative 2. So x equals negative 2. So your line of symmetry, if you want to draw it right now, is at negative 2. And you know your vertex is going to be somewhere on this line. And remember, I take negative 2 now to find my vertex. And I plug it in. And don't worry about that. It's just going to be 1. So negative 2 and negative 2. So y equals negative, well, 2 times negative 2 squared is 2 times 4. 8 times negative 2 would be minus 16. Minus 5. So 2 times 4 is 8. Minus 16 is negative 8. Plus 5 is negative 3. So y equals negative 3, which means that my vertex is the combination of these two. So it's negative 2, negative 3. So I'm going to go ahead and just draw that right now. All right, the y-intercept, remember, is just 0, c. Okay, well, what was c? Negative 5. So it's 0, negative 5. So I'm over at 0. I go down to negative 5. Wait a second. 0, negative 5. Wasn't this supposed to open up though? Hold on a second, folks. Somebody find my error. Let's see. Negative 8 over 2 times 2 is negative 8 over 4 is negative 2. That's right. Plug in 2 times negative 2 squared. So negative 2 squared is 4 times 2 is 8. Plus 8 times negative 2. So that's minus 16. So 8 minus 16 is negative 8. Oh, well, minus 5, so it should be negative 11. But that still doesn't make sense because you still open up. Hold on. What on earth? Okay. Hold, please. So, 2x squared. You can't see what I'm doing. I'm putting this into my calculator because this is bothering me now. Plus 8x minus 5. Yeah. Oh, for crying out loud, it didn't do anything. That was stupid. Two x squared plus 8x minus 5. Graph. Yeah. Negative. Oh, I know why. Okay. Da. You guys probably already saw my error. And it is that I was adding 5 by accident instead of subtracting it. So that is going to be negative 11. Haha. And I bet you I can like name the people in each hour that would have been raising their hand going, are you sure that Mrs. Shipley, isn't that negative 11? Yes, it is. So thank you. So 2 times 4 is 8. Minus 60 is negative 8. No, my gosh, 13. What is wrong with me? I should have stopped this recording right now. This is why I shouldn't do things on Sundays. It's like my brain isn't doing math right now. All right, so 8 minus 16 is negative 8. Minus 5 is negative 13. Good Lord. All right, so are you confused yet? I am. Anyway, my point is negative 2, negative 13. Negative 2, negative 13. Right there. See, but, all right, then on 0, negative 5, that's my y-intercept. So the reason why I knew I was wrong before I did it is because, like, this negative 5 right here is my y-intercept, right? And I use this to draw my parabola. So because this is a line of symmetry, that I know, like, if it's 2 over from here, it's going to be 2 over here, right? So there's 2 on the right side of the line of symmetry and 2 on the left side. And so I knew it was wrong. If I just draw my little parabola here. I knew it was wrong because when I had my axis of symmetry up here, it would have gone down. But I knew that it was supposed to go up. And so I knew that it was wrong. And like, that's what you guys should do too, is to take a look and see, okay, well, wait a second, like, does that even make sense? And it didn't. And then of course, the solution is a mathematical error on my part because, why is it super important for your math teacher to be able to, subtract instead of add? Anyway, all right, maybe the next one will go easier. Let's all hope, right? I should have just stopped and re-recorded it, but I didn't feel like it because I also think it's important for you to see that I'm human. I know you knew that. Okay, so y equals negative x squared minus 2x plus 2. A is negative 1. B is negative 2. C is positive 2. Which way is it going to open? A is negative. So it's going to open down. It's going to be sad face parabola. Axis of symmetry. X equals negative b over 2a. So x equals negative or opposite of 2. So negative of negative 2. That is so important that you have both of those negatives in there or else your axis of symmetry will be wrong. And then over 2 times a, which is negative 1. Okay, count your negatives here. 1, 2, 3. So my answer is going to be negative. So this is positive 2 over 2 times negative 1 is negative 2. So this is negative 1. So x equals negative 1. And that's my axis of symmetry. Okay, even though mine doesn't hit the line because of my 4. All right, so now remember I take negative 1 and I plug it in. So negative 1 here, negative 1 here. So negative of negative 1 squared minus 2 times negative 1 plus 2. It's a lot of negatives. Just to make sure you're doing this all correct. And I'm talking as much to myself as I am to you. All right, so negative 1 squared is positive 1 times negative 1, or times the negative is negative 1. And then this minus 2 times minus 1, that'll give you plus 2. And then plus 2. And now I'm like seriously questioning all of my math skills right now. All right, so negative 1 squared is 1 times negative 1 is negative 1. Minus and minus will give you a plus 2 plus 2. So negative 1 plus 2 is 1 plus 2 is 3. So I have negative 1, 3. So that's my y value as my vertex. So negative 1, 3. Okay. My y-intercept is 0, c. So it's 0, and then my c value is 2. Oh gosh, this works. No, 0, 2. And then remember, like, this is my axis of symmetry. So I move 1 over from the axis of symmetry to my y-intercept. So that's to the right. Then I move 1 over to the left. And now I draw my parabola. And in theory, like, these points, these solutions, like, we would know them more specifically, but we don't. And that's okay for now. Doesn't really matter. We'll get there. Okay. Last example. Using the function y equals x squared minus 4x plus 3. So find phi. A, 1. B, negative 4. C, 3. Which way is it open? Well, A is positive. So it opens up. Axis of symmetry. Oh, you don't have anything written for you now. So now do it all ourselves. X equals negative b, or opposite of b, over 2a. So opposite of b, so opposite of negative 4, over 2 times a, which is 1. So negative of negative 4 is positive 4, over 2 times 1, which is 2. So that's 2. So x equals 2. Now go ahead and draw that axis of symmetry right here. Now I'm going to take this and plug it into the equation. So my equation is y equals x squared minus 4x plus 3. So this will be 2 squared minus 4 times 2 plus 3. So 2 squared is 4, minus 4 times 2 is 8, plus 3. 4 minus 8 is negative 4, plus 3 is negative 1. So y equals negative 1, and put those two together, my coordinate point is 2, negative 1, which is kind of like here-ish. All right, and then my y-intercept, which is 0, c. C is 3, so it's 0, 3. And again, we get it right, yay, 0, 3. So I'm 2 to the left of the axis of symmetry, so I have to walk 2 to the right. Put a point right there. Make it look kind of like a parabola. And we're good. Okay, so that's how to do that. I've also included a graphic organizer just so you can kind of remember. And you can get all this information from the the initial note sheet that you did. So does it open up or down? That's from A. If A is positive, it opens up. If A is negative, it opens down. Easy enough. Axis of symmetry, your formula is x equals negative or opposite of b over 2a. And I might write opposite of b, just so you remember that negative is going to, if b is already negative, you have to make it positive. So this is the x coordinate also of your vertex. So then for your vertex, also a minimum or maximum or turning point, if you will, use the axis of symmetry for that x value to plug in to the equation and find your y value. So your coordinate point is your axis of symmetry and your y value. And I have the graphs here, just I don't really remember for what purpose, but you can graph some things on them if you want to. And then the y-intercept, of course, is 0, c. So in y equals ax squared, oops, oh, geez, oh, Pete, okay. And y equals ax squared plus bx plus c, it's that. If there is no c, then the y-intercept is 0. Okay. I think, yeah, that's it. So you guys have, well, it's it for you, not it for me. It's it for me. You guys have a whole bunch of these to do and just to practice. So also, I will remind you that it's not a horrible idea to check it on your calculator. You can also plug in your axis of symmetry into your equation to find the vertex. You can do that in your calculator as long as you put parentheses around each one of them when you do that. Because otherwise it'll get really kind of confusing. All right, there you go. If I confuse you too much with the first problem, I do apologize for that. If you still are a little bit lost, there are some pretty good Khan Academy videos that you can just search if you want to do that too. All right, thanks for listening and watching and taking notes. Enjoy your day.